Alright folks, a little country music to get us into Chapter 8, Section 4. Here in Chapter 8, Section 4, we're going to study negative exponents, and we're going to study zero exponents. That's Chapter 8, Section 4. Alright, here in Chapter 8, Section 4, let's go ahead and dive right into negative exponents. Now let's just go ahead and review a basic exponent, a basic power, such as 5 squared. 5 squared, we know, equals 5 times 5. The exponent of 2 tells us to multiply the base 5 2 times. So 5 times 5 is equal to 25. Alright, now what do you think 5 to the negative second power is going to be? Well, that confuses students because they're like, wait a minute, how can you take 5 and multiply it a negative 2 times? Well, that's where the definition of a negative exponent comes in. The definition of a negative exponent is that x to the negative n equals 1 over x to the n. So if we take that definition and apply it to 5 to the negative second power, you can see that we can get rid of a negative exponent simply by taking it and moving it into the denominator. So 5 to the negative second power would be the same as 1 over 5 to the second power, which we all know 5 to the second power is 25. So we'd have 1 over 25. Let's apply this rule to a variable example, such as x to the negative sixth power. Well, x to the negative sixth power, if we apply the definition of an exponent, would be the same as 1 over x to the sixth power. Let's help you understand negative exponents a little bit better by doing a few more examples. These would be 3 good examples to put down into your notes. Number 1, 2 to the negative third power times 2 to the second power. So if we go ahead and multiply these two terms, we see that they have like bases. When we're multiplying with like bases, we can simply add our exponents. So we would take our exponents and add them together, and we would get 2 to the negative first power. Now we don't want to have a negative exponent, so to get rid of the negative exponent, we take it and we move it to the denominator, and it becomes a positive exponent. And 2 to the first is the same as just plain old 2. So our answer would be 1/2. Example number 2, we have 7 to the 5th divided by 7 to the 7th. So our quotient of powers property tells us that when we are dividing with like bases, we subtract our exponents. So if we subtract our exponents, we'd have 5 minus 7, which is negative 2. So 7 to the negative second power, well, we can simplify that even further by using our definition of a negative exponent. So we take 7 to the negative second power, we move it to the denominator, it becomes 7 to the positive second power, and then 7 squared, we all know, is 49. So our final answer is 1/49. Example number 3, x to the third divided by x to the 7th. Here we're dealing with 2 variable terms. Once again, when you're dividing with like bases, you subtract your exponents. 3 minus 7 is negative 4. So you would have x to the negative fourth, which you could simplify that even further by getting rid of your negative exponent by taking your term and moving it into the denominator. So you would have 1 over x to the 4th as your final answer. Those are 3 additional examples which hopefully better help you understand negative exponents. Alright, we're ready for the second part of Chapter 8, Section 4, and that is 0 as an exponent. This rule says that for any non-zero number, x to the 0 power equals 1. In other words, guys, what you need to understand is that anything to the 0 power always equals 1. So, for example, 50 to the 0 power equals 1. N to the 0 power equals 1. Anything to the 0 power equals 1. I would write that down in your notes right now. Anything to the 0 power always equals 1. So, 100 to the 0 power, guess what it equals? 1. Mr. Simpson to the 0 power is equal to, guess what? 1. Anything to the 0 power always equals 1. Write that down in your notes. I said that for the 3rd or 4th time right now. Put it in your notes. Anything to the 0 power always equals 1. Alright, ladies and gentlemen, now that we have those two new properties installed, let's go ahead and try a few more examples. Now, these examples are very important to you as a student because not only are these examples that I'm going to do here on out with or for the rest of our presentation, not only do they use the two new properties, but they also utilize the previous properties that we learned in 8.1 to 8.3. So let's go ahead and see if we have the ability to put all of these properties into action. So here's the example: 42x cubed y squared z over 6x to the 8th y z to the 3rd. Now this is a division problem. So when we divide monomials, we go ahead and we divide our coefficients. So 42 divided by 6 would be done first, and 42 divided by 6 would be 7. And then we subtract our exponents. So we have 3 minus 8 for x, 2 minus 1 for y, 1 minus 3 for z. So then we come out with an answer of 7 x to the negative 5th, y, z to the negative 2nd. Now that answer can be further simplified. We have two variables that have negative exponents, x to the negative 5th, z to the negative 2nd. So we go ahead and we get rid of those negative exponents by taking those two variables and moving them into the denominator. And by our definition of an exponent, when we change heights with the variable, it's going to change the sign of your exponent. So negative 5 and negative 2, when they get sent to the basement or the denominator, they are going to change signs and become x to the 5th and z squared. So that would then be your final answer. Now might be a good time to pause this and make sure you have this example down in your notes. It's a good example because it's an example that makes us utilize several of the properties that we've learned here in Chapter 8. Alright, last part of our lesson, ladies and gentlemen. Here's what I want you to do. I want you to go ahead and now try these three problems on your own. Give them a try on your own. So right now, go ahead and push pause, copy the three problems down, give them a try. Alright, go ahead and hit pause right now. Hit pause. Alright, hopefully you've had a chance to go ahead and solve these three problems. Now I'm going to take you through how to solve them, so you can go ahead and check your work here. I'll go through this fairly quickly. When you're multiplying with like bases, what do? We add our exponents. What's negative 5 plus 3? Negative 2. So you'd have 7 to the negative 2nd, which can be further simplified to be 1 over 7 squared, which would have a final solution of 1 over 49. Number 2, we can simplify the top. A to the 5th times a to the negative 5th. Well, when we're multiplying with like bases there on the top, we add our exponents and we get a to the 0 power over a to the 8th. Okay? Anything to the 0 power is the same as what? 1. So our final answer would be 1 over a to the 8th power. And then example number 3. Example number 3, we're dividing. So we look to simplify our coefficients by dividing. 3 over 36 is the same as 1 over 9. Then when we subtract our c's, our exponents of c, 6 minus 4 is 2. So we'd have c squared. And then our last one, d to the 3rd divided by d to the 8th. 3 minus 8 is negative 5. Now, since we have d to the negative 5th power, we don't want to have a negative exponent. So where would we put that d? We'd put it in the basement as a positive. So our final answer is going to be 1c squared over 9d to the 5th. All right, ladies and gentlemen, that concludes Chapter 8, Section 4. Hopefully you have some good notes over this information. Please keep in mind you can always pause, rewind, do what you need to do so you learn the information that is needed from this video. Thanks for listening. Have a good night.
Made with Doodlecast Pro.